Hello everyone. Myself Dr. J. Sindar Kumar, Assistant Professor, Department of Computer Science and Engineering, Kalangar Karani Institute of Technology, Coimbatore. So this is a topic related to subject called deep neural networks. That is how we are going to learn about the neural networks. We have the definition about the neural networks. What is neural networks? Regressions and predictions. So these are the things will happen in neural networks. So what is happen in neural networks is what is the purpose of the neural networks is to find the Okay, for the tasks such as and classifications, regressions, and predictions. Why it is called as neural networks? So it is working based upon our brain structures. Okay, where we are using this neural networks in the form of a deep learning format. So what is the deep learning? What is the purpose of deep learning? It is a subset of an AI. To find the image data or an video data, we have to use this neural networks. So these are some things is happening in neural networks. So what is an extra format of a neural networks is an basic structures. We have the input layers, hidden layers, and output layers. So most of the neural networks will be working on this part of an input layer, hidden layers, and output layer. So what is an input layer? It receives the raw features, and hidden layers they perform the nonlinear transformations using the weighted sums and activation functions. The output layers is produce the final predictions. So this is the structure of a neural networks. So you can see that the brain structure of a neurons, like our brain have that input layers like this, and we have that like and this one, these functions is come under the form of an hidden layers. This process we are calling as an output layers. So with the help of this three part, same as an we have the input layer and we have the weight and bias like an hidden layers which is used to calculate the modify the weight and bias. Finally, we will get the output. Okay, here we are using this linear functions and activation functions which is used to calculate it or an weighted sums which is used for the calculating and modifying the weight and bias. Finally we will get an if you're getting a minus values, then it have to convert it into positive values with the help of an activation function. So these are the things happen in neural networks. So everything will be viewed in this sessions, right? What are the key components of a neural networks? The neural networks are capable of learning the identify the pattern directly from the data without predefined rules. These networks are the built for several key components. So we have some several key components for in the neural networks. What are they? So we have some neurons, that is the basic units of the receive the inputs, such as neuron is governed by a threshold. So we have using of threshold. With the help of this threshold values, we will be setting an setting these values into in the form of a minus or zeros like this. We'll be setting in the value in the form of a threshold, and we'll use that activation functions. Then we have the connections, the linking between the neurons. So what is the linking between neurons is we have the neurons like this. So we had to add and make it to another neurons. So like that linking between the neurons that carry the information regulated by the weight and bias. The weight and bias is the parameters determine the strength and influence of the connections. The propagation functions is a mechanism that helps the process and transfer the data across the layers of the neurons. We have the learning rules, so it will be come under the learning rate. So it will be using of an learning as an alpha, the method that adjusts the weights and bias over the time to improve the accuracies. So these are the key components used in the neural networks. What are the three stages of process? Is we have that input component computations data is fed into the networks. The output generations based on the current parameters that the networks generates an output, and iterative reinforcement that is used for the reinforce the output by the adjusting the weights and bias, gradually improving its performance and the desired tasks. So we have the adaptive layers environment. The neural networks is an exposed to simulate the scenarios or data sets. The parameters such as weights and bias are an updated in the response to the neurons or in conditions. With each adjustment, the neurons and networks response evolves in the allowing the adaptation effective to different tasks or an environment. Where it is started, how it is started, the neuron started from the informed ignorance, and it begins the 2 points. So where it is begins, we have the structures and we have the initialization. So this is your decision choice that we have to decide how much neurons we have to make in the neural networks. Suppose if the values is if we having 784 neurons, the pixel size, if the pixel size is 288 into 88, pixel size. The hidden layers and the neurons, the networks is the depth and width for the processing, and output layers is in shape matches like an 100 neurons for the digits of the zeros and two ones. This is like to deciding to build a factory with a specific assembles lines before the hearing ones. Then we have the initializations. So what is the initialization is before training all the knobs of weights and bias that connected neurons are set to small random numbers. This randomness is crucial. It ensures that each neurons start learning the something slightly differs. It's like an starting a maze from the many different. The random entrance points to the find the best path. So this is the where we are. It's where it's neuron is begins. Next, we are going to see about why of the neurons. That is we are calling as purpose. Okay, what is the purpose of this neural networks? To find the complex numbers, hidden patterns in data that are impossible to prehend with explicit rules. Think automated, sophisticated pattern decisions. So we have a simple analogy that is an imagines teaching a child to recognize cat. So we are going to teach to the child to recognize that. So what is the way to teach to the child is to we have to say that it has an feather length and ear shapes to teach to the child. So instead of teaching to the machines, so how will we teach to the machines with the help of an images like an picture data and say it is a cat and not cat, which is not a cat like a dog we can mention like that we can differentiate, right? Their brains networks figure out the patterns on its own, and the neural network does the same with the data. Then technical purpose, it is an universal function approximators that are given enough data and right structures. It can learn the approximates almost any relationship between the inputs and the like in pixel and the cat. So this is the why we need of neural networks, right? Next, what are the applications? So we are calling us when to use the neural networks, right? When we are going to use the neural networks, when it is in complex, like an image, audio, languages, like an speech. Here, if you are using for the tabular method, we have to use the simpler model, right? Then, if you're going for an hidden patterns like an objects recognition, sentimental index, we have to use the neural networks in fully transparency and interpretability for the decisions. You have the massive amount of label data to learn from it, and we have little data for or neither traditional algorithms like an decision tree, linear regressions hits the performance well. You are solving the classical well-defined statistical problems when this is the applications and where when to use the neural networks, right? And how it is using, that is a mechanisms. Here we can see this mechanisms of an process to continuous iterative loop. The forward pass is make and predictions data in feed it in the input layers. It flows through the networks at the each networks input are multiplied by the weights and some will pass through the activation functions, which is if you are going for a minus less than of zeros, we have to use the ReLU functions. How match to activated. Then finally, the output is ended with an 85% of the cat is marked. So it is a mechanism for the neural networks, and we have to use the loss classifications, loss calculations that measure the errors. While learning or training the data sets, we have to learn the data sets. We have some minus data, we have losses in that data sets that have to cure with the help of an mean square errors or cross entropies. The loss functions the compares their predictions to the truth table. So it is a cat, and the output single tables, the cause or errors, the low is better. So the importance of the neural networks, the identify the complex patterns, learn from the data, key drive the key technologies, boost the efficiencies, backbone of the AI. So these are the importance of neural networks. And layers we have already we have seen that input layers, hidden layers, and output layers, right? Here, what is the main concept is the computation is a heavy lifting, and neural networks can one or multiple hidden layers. Each layer contains of units that transform the input into something that the output layers can be used. So this is an input layer, and here we have the hidden layers, which is used to calculate the weight and bias, and we can modify the. We have to find the loss function, and with the help of an activation functions, we'll get an output layers, right? So this is the flow structure. Actually, this is in the form of an feed forward. Okay, we'll be studying about the feed forward neural networks. So this is the structure of a feed forward neural networks, right? You can see that input values and you can see that out the weight, and with the help of the bias it will be calculated. So this is the equation to calculate. After this we have to check whether it is an exactly correct or not with the help of an activation function. So with the help of an activation functions all together, and we are making as an output that we are calling as a predictions. Okay, with then calling as an we are calling as a prediction for that data sets. So artificial neural networks, that is a mathematical model. We have, if you're going for, this is for the single input and single output. This is for the multiple inputs. Suppose if the weight is n number of data sets we have, that we can go for this kind of an xi input, wi weight, and b is a bias. This is an activation function, and y is an output. So this is a artificial neural networks, that is in the form of a mathematical. Then working of the neural networks. So what is how it is working? It is an when the data is an input to the networks, it passes through the networks in the in the feed directions, okay, in forward directions from the input layer through the hidden layers to the output layers. This process is known as an feed forward. Forward propagations. As I mentioned here, you can see the data sets is moving from this part to this part. So this one we are calling as an feed forward neural networks. And we have that linear transformations. Each neurons in the layers receive the inputs, which is then multiplied by the weights associated with it. So this is with the help of these equations, I am calculating the weight and bias, and we are producing the output of an EZ, right? Then activation functions, after getting the z values, with the help of we had to check, after getting the z values we had to check passes through the activation function. Activation function is crucial because it is interfaces the non-linearity. Suppose the value is less than 0 or in minus values, so what I have to do in pixel, in an image we don't have this kind of an images. Okay, if we don't have the this kind of an values, we have to convert into an positive values. So for this we have to use this activation functions. So what are the activation function is available? Sigmoid, ReLU functions, tanh function, and soft functions. What is the purpose of an sigmoid function is for the binary classifications, ReLU for the depth networks, and tanh for the zero centralized, and softmax for the multiple classes. Then we have different types of activation functions and its equations, and it's an example here, and this is the 1D graph. So just we again go for a maximum of ReLU functions. This is a rectified linear units which is used to calculate at minus value to the positive values. So back propagations, suppose if you're going for a loss functions, loss calculations, suppose we are the weight is not in proper. So initially the weight is 0. Okay, initially the weight and bias is 0. We had to calculate, we had to recheck the weight to from the backwards to calculate the weight. Okay, that is the loss functions. And gradient calculations, the network computes the gradients of the loss functions with respect to each weights and bias in the networks. This involves applying the chain rules of the calculations to find out how much each part of the output layers can be contributed to each weight and bias. So finally, we have the weighted updates. So with the help of an calculating the loss and gradient descents, we'll update the weight to make the changes, and with the help of an stochastic gradient descent algorithm. We have the iteration techniques. This is the process of forward propagations, loss calculations, and backward propagations. Weighted updates is repeated for many iterations over the datasets. Over time, this iterative process reduces the loss and the network's predictions becomes more accurate. Through these steps, the neural networks can predict their parameters to better approximate the relations in the data, thereby improving their performance on the tasks such as classification, regressions, or any other predictions model. So these are the working of neural networks. First one, we have that forward propagations, activation functions, back propagations, and iterations. Let us see some one example, that is the mail is spam or not. So here, what are the keyword is we are going to see about the get free gift card now. Here you can see the exclusive offer. So we are going to mark this as offer free or an keyword to calculate that whether the spam is, the email is spam or not. Okay. Here you can see the free win offer, and it is represented in the form of an, if it is present it is in 0, if it is absent it is in 0. If it is present it is in 1, if it is 0 it is an absent. Okay. And how it is work in neural networks, the input data is passed to the multiple layers, including one or more hidden layers. Each neurons in this hidden layers performs the several operations transforming the input into a usable output. The inputs layers, that is, we have the three nodes that indicates the presence of each keywords. So suppose we have free, okay, we have like this, right? Free, gift, like this, okay. We have three neurons. We are calculated with the help of this, assuming the values like this, okay. Minus 0.5 minus value and 0.3. So we are assuming the value like this, and we have the vectors, that is 1 0 1, okay. If you calculate the values, you will get an h1 is 0.8 and h2 is minus 0.1. So here what is happened here is we getting a minus value. In an image we don't have any negative values. What we'll do, we'll be converted with the help of an activation functions, with the help of an reload techniques. I am converting this minus value to the positive values, that is in zeros. Okay, after calculating these values, you can see that activation functions, at last we'll get this 0.5 as an summed weight, like after the sigmoid function applies, we'll get this 0.636 indicates the probability of email begins the spam. Since this value is greater than 0.5, the neural networks classify the email as 0. That is a spam. Okay, so if it is in 0 point less than 0.5, if the values, if you're getting the less than 0.5, then it is not a spam, right? So next we are going to see about the types of neural networks. So this, with the help of this types of neural networks, we'll be calculating the weighting bias, and we, the most important algorithm, that is a basics algorithm, is we are using this feed forward neural networks and convolutions. So it is a very important algorithm for all the basics image classifications. Other things are an it is an important, but we will be focusing more on that, because if you understand the convolution neural networks, you can easily understand this kind of a neural networks. Okay, what is the types of a neural networks? We have forward neural networks, a single layers perspectrons, then multi-layers perspectrons, convolution neural networks, and recurrent neural networks, long short-term memories. So these are the different types of neural networks. Feed-forward neural networks, it is a simple artificial neural network architecture in which data moves from the input to the output in a single directions. It has in one layers, and it applies the weights, sums inputs, and uses the activation to produce the output. Multi-layers perspectrons, it is a types of feed-forward neural networks with then three or more layers, including the input layers, one or more hidden layers, and output layers. It is used for the non-linear activation functions. Then we are going for a convolution neural networks. It is designed for the image processing. It uses the convolution layers to automatically learn the features from the input images, enabling the effective image recognition and classification. Handle sequential data using the feedbacks loops to retain the constants over the time, right? Okay. Recurrent, so handle the sequence data using the feedback. So with the help of the feedback, what is this happen is the learning the data again and again, and we'll get the feedbacks loops to retain the content over the time. So LSTM, so the type of an RNN with the memory cells and get it to the handle long-term dependency and avoid the vanishing gradient. So these are the types of neural networks. Next, we are going to see about the advantages of neural networks. We have adaptability, pattern recognitions, parallel processing, and linearity. So, what is the purpose of this of the neural networks? We are using for the useful for the activates where the link between the inputs and the output is complex. So, when you're going for the complex, we will be using of a neural networks are not well defined because they are adapted and new situations learns from the data. Pattern recognitions, it is an render that is used for like an audio and image identification, natural language processing, and other data patterns. Parallel processing, that is because of neural networks are capable of parallel processing by nature. They can be processed in numerous job at once and speed up the improves the efficiency of the computations. And non-linearity, so neural networks always work on the non-linearity, that is a model and comprehend complicated relationship in data. And non-linear activation function found in the neurons, which overcomes the drawbacks of the linear model. What is the limitations in this neural networks? We have the computational intensity, black box nature, overfittings, and need a large number of data. So these are the limitations of the neural networks. So what are the applications we will be using in the form of an image and video recognitions, natural language processing, finance, healthcare, gaming. So more number of applications that we are using nowadays. So these are the some important applications which is used in the neural networks. So here we are using as gaming and automation systems, which is used for the taking the decision makings, enhancing the users video games, and then enabling the autonomous like and self driving, because we are using this kind of an applications. So these are the some neural networks working structures and the process of neural networks. Hope you understand this neural networks. So thanks for the listening, and subscribe my channels. Thank you.